Good afternoon, students. Today we'll be talking about the band theory. So in band theory, what we talk about? We talk about the electrical conductivity of solids. This could be a conductor, an insulator, or a semiconductor. So first of all, a conductor, what is this? So according to band theory, it says in a solid material there are two types of bands. One is called a valence band and another one is called a conduction band. So usually the valence band, it is filled with or partially filled with electrons, and the conduction band usually it is empty. So according to valence band, according to band theory, it says whenever we have a solid, there are two types of bands. One band of what? Band of orbitals. So the valence band, it is made up of orbitals which are occupied by electrons. It can either be completely filled or partially filled. Whereas in case of the conduction band, it is completely empty. Now band theory says the electrical conductivity is due to the movement of electrons from the valence band to the conduction band. If the ease of moving the electron is very simple, then it will be a good conductor. But if the electrons cannot move easily from the valence band to the conduction band, it will be an insulator, right? So let's discuss about a conductor. So what is a conductor? So if we draw, this is the energy axis. So here is our valence band. And for conductors, here is the conduction band. So the valence band and conduction band, the energy gap between them is very low. In fact, they actually overlap with each other. Therefore, electrons can freely move from the valence band to conduction band. So what we can note here, the band gap is very low, and thus electrons can move easily from valence band to conduction band. However, in case of insulator, what happens here? Again, if we draw the energy axis, this is, we have the valence band, and is completely or partially filled up with electrons. And this is your conduction band. So usually this is called the band gap. Usually the band gap in case of insulator is pretty high, and it is actually more than 5 electron volt, 3 to 5 electron volt. So as a result of this thing, as the band gap is considerably high, so electrons cannot move from valence band to conduction band easily. right? So this is the second situation, the insulator. The third situation, however, it is slightly interesting. It is about semiconductors. So from the name itself we can understand there is some extent of electrical conductivity in this case of in this type of solids. So here what we observe, if this is the energy axis, this is your valence band, and the conduction band is here, and the band gap we can easily observe from the diagram itself. It is considerably low than that of insulators. So this is your band gap, and usually the band gap is 1, 2, 3 electron volt. This is the band gap. So as the band gap is intermediate, that is, it is not as low as good conductors, it is not as high as insulators. Therefore, there is a slight electrical conductivity in this case of solids, and thus they are called the semiconductors. However, one more thing, when temperature increases, some of the electrons, they can easily move from the valence band to conduction band, leading to the increase in electrical conductivity for semiconductors. So this is all about band theory.